guys, let's solve this kind of tricky integral. Here I've given you guys the hint that substitution doesn't work here. So what should we do now? Well, is there any way that we can use the DI method, the integration by parts? Well, one into that, no. Partial fraction method, but the denominator has to be multiple of 2. Gets a bit crazy, but no. But you have to think kind of not so deep, not so into calculus, but as algebra, as your typical 8th or 9th grade simple algebra problem without this dx and without this integral sign. So it becomes the question, simplify the inside, right? Just simplify this term, and to do that you see the root and then you just rationalize it. It is in fact just that simple, and let's do that. So to rationalize these types of terms, you have to multiply the numerator and denominator by its conjugate, like so. So on the top we have x minus root x square minus 1 dx by, here we have something plus something into something minus something. So basically a plus b into a minus b, which is just a square minus b square. So it's just going to be this square minus, root x square minus 1 whole square. And here the nice part is the 2 and root cancels. So we have x square minus 1. Now we can just directly do that. We don't have to do every next step. So x square minus x square plus 1 when we open up the bracket, and here x square and x square cancels, giving us positive 1 or just 1. Meaning we just have this numerator part over here, and we can just directly do this integral, or not directly, but for this one we can. So it's just the integration of x minus the integration of root x square minus 1. So for the first one is just x squared by 2 minus the integration of root x square minus 1 dx. Now here you can directly use the formula for these types of integrals and we'll get the answer right away, or you can do whatever you want to get the answer over here, whether it be partial fraction or DI method, integration by parts, or the simple trigonometric substitution. Not that simple, but easy to understand and evaluate. And I'll just give the standard formula for these types of integral. So let's say it's the integral of x square minus e square dx. Well, the answer for this is first x by 2 root over x square minus a square, basically what you have here, minus a square by 2 log natural of x plus whatever this root is, x square minus a square, and then of course our plus c. So in fact, when you do trigonometric substitution, fractional, partial fraction, any of that, in the end you'll simply get this, because in fact to get this formula you'll have to use one of those methods to prove it, right? To derive this. So ultimately in the end you'll get this formula over here, and this is just the special case, and this one right here you can write as 1 square. So it's just a case when a is equals to 1. So x square by 2 stays the same. This becomes minus x by 2 root x square minus 1, but don't forget this minus, so this becomes minus minus plus a square. Here a is 1, so this is 1 by 2 log natural of x plus root x square minus 1 plus c, and that is it. This integral on its own seems kind of difficult because, I tried to do this just for substitution for about 10-15 minutes, substituting u square equals to, substituting the root, substituting whole thing, everything with substitution. That's why I told you guys to not use substitution. Just don't do that, and just think algebra, just think simple. And If you learn something new, please like and subscribe. Thank you.